ladies and gentlemen, let's take a look at this. B represents our base. What does B have to be in order to have a growth? B needs to be greater than 1. What about a decay? Just less than 1? Between 0 and 1. Because B cannot be negative or 0. Good. All right, so as an example of this, f of x equals 2 times 3 to the negative x. How can we rewrite that? What do you want me to change? Do you want me to change? Good. We're going to change 3 to 1 over 3. And what do we do with their exponent? Make it positive. So now what type of function is this? Exponential decay. Because we have 1/3. Did we have to rewrite it in order to determine if it was growth or decay? No. You could look at it and say, oh, okay, well, I would originally say the B is 3. That would tell me growth, except for I have the negative. Remember, whenever you have a negative, you need to think opposite. All right, coefficient of A represents our initial value. So when x equals 0. An A value other than 1 means that a vertical stretch or compression. When do we have a compression? Good. When A is in between, the absolute value of A is between 0 and 1. And when do we have a stretch? When the absolute value of A is greater than 1. Questions on A and B values? Do you remember doing these yesterday? All week? Yeah? Okay, we've also looked at the parent graph being reflected over the x or y axis. Negative A value means, which axis are we reflecting over, x or y? X. And a negative x value, negative exponent, means we reflect over the y axis. Good. All right, so what is the only type of transformation that we have not talked about yet? Talked about reflections, we talked about dilations, left and right, up and down. What do we call those? Do you remember? Translations. So we're going to get into that today. So we're going to consider these two functions, and we're going to pick some nice x values. So what is the smallest x value that you would probably like to use?
0.
0 wouldn't be 1? How about less than that?
0.5.
Do you really want to deal with decimals?
Well, you said less than that.
How about less than 0?
-1.
-1 would be a good one. How about -2?
Yeah, that would be another.
So we'll use these 5 right here. We know our perfect squares, yes? So this works. So -2, if we're going to look at f of x equals 3x, what is 3 to the -2nd power?
9.
The negative tells us what? 1/9. The negative tells you need to take the reciprocal, which would be 1/3. And what is 3 squared? 9. So we get 1/9. What is 3 to the -1st? 1/3. Anything to the power of 0 is? 1. Uno. Anything to the power of 0 is 1. All right. 3 to the 1st power. 3 to the 2nd power.
9.
That was easy, yes. Ladies and gentlemen, this is going to be something so that you might see on an assessment, okay, where I'm having you, either I'm giving you these easy numbers or you get to pick your numbers, okay, but you should have plenty of dots on your graph, plenty of points to plot, okay? All right, let's look at g of x equals 3x plus 2. Ooh. G of x, 3x to the power 3 to the power of x plus 2. What do you think this is going to do? It's inside the exponent. Okay, it's going to be a translation. What direction? Left? You're saying left? You're someone saying right? You're saying up?
I'm saying left.
Left? All right, let's find out. All right, let me ask you this. What number would you like to have as your exponent? You want 0? So what plus 2 would give you 0? What kind of 2? Negative 2. So let's do negative 2. Okay? So here, we're going to come off here. Let me change colors. If we look, I'm going to come here and say 3 to the negative 2 plus 2. What's negative 2 plus 2? 0. What's 3 to the power of 0? 1. All right. What other number would you like to plug in for x?
Negative 1.
-1. Okay, when we plug in -1, we're going to get 3 to the -1 plus 2. What's -1 plus 2?
-1. Wait, 1.
Positive 1. What is 3 to the first? All right, pick 3 more values you would like to plug in.
0, 1, and 2.
She's not here. Okay. Pick 3 more values, plug them in.
0, 1, and 2.
You pick them, you do them.
We did pick them. We did. Yeah.
Okay, then do it. Do it on your paper.
Oh.
Do it on your paper. All right, Evan, you said 0. What did you get?
9. Wait. Yeah. 9.
Yeah, 9?
I got 9.
All right, what's another number we plugged in for x? 1. What did you get?
27. 2, 81.
All right, let's go ahead and plot these. If you would like a highlighter, I would suggest, because we're going to have to graph both of these functions on one graph. I would say get out either 2 different colors to help you out to tell the difference. I'm going to do my first one, my original function, f of x in blue here. I had -2 1/9, -1 1/3, 0 1, 1 3, and 2 9. Go ahead and graph your g of x function. I'm going to come around to highlighters if you want a highlighter. Or maybe you want to grab a red pen, so you can do 1 in pencil, 1 in pen. When we graph g of x, if we look, -2 is at 1, -1 is at 3, 0 is at 9. Can't really graph anymore, right, from the ones I chose? So I'm going to come here and I'm going to say, real quick, I'm going to do off to the side, if I had 3 plugged in -3, that would give me 3 to the -1st, which would be 1/3, just so then I have an idea of where this graph is going. So I just made one more point. So how did this move? What's the transformation? Good. So we translated or shifted 2 units left. questions on how we know that? If you look, just in case, if you see, going from one of my blue dot here on as my y-intercept over to where I get 1 on my green, we have 2 units to the left. Thank you. All right, so let's figure out the characteristics of g of x. Which one is g of x, my blue or my green? Green. So characteristics of g of x. So what is the domain of all exponential functions? All real numbers, -infinity to infinity. What is the range? Good, 0 to infinity. We're not crossing that x-axis here. We didn't move it up or down. We only moved left or right. So that did not affect my asymptote. Where's my asymptote? Y equals 0. What is my y-intercept? 0, 9. All right, end behavior. Let's set up the notation first. The limit as x is approaching the left side, -infinity. What is the function doing? Don't answer. And the limit as x is approaching the right, +infinity. What is the function doing? So as I go left, as x is getting smaller, where's my function going? 0. As I go right, where's my function going? To infinity. And are we increasing or decreasing? Increasing on what interval? -infinity to infinity. Yesterday I saw a lot of people just saying increase or decrease. They're not just asking you for what the function is doing. They say interval. So you need to write -infinity to infinity. I'm going to tell you, if you don't write your interval down, it's wrong. Yes, because you're not answering the question. Okay? All right, so we know inside the function here, inside the exponent, are we going to go horizontal or vertical translation? Horizontal or vertical? Horizontal, inside the exponent, just like with quadratics, when you're inside the parentheses, it's horizontal. And we have to think opposite of that sign. It says +2, but we really went -2. Okay? So our next one is outside the exponent. It's 3 to the x -5. What, Ashley? You're saying down? Do you guys agree with her? Yeah. Let's find out. So I would say we probably want to use the same numbers of our x values for our original function 3 to the x, yes, from above? Yeah. So remind me, what were those values, x values? We had -2 what? Look at your table up above. -1 was 1/3. Yes, you guys remember the table up above at the top of your page for f of x? Yes, those are the numbers I'm using. 0 would be 1. 1 is 3. 2 was 9. All right, let's take a look here. We're not affecting the exponent. So give me some values that you want to plug into this. Evan, you want to do -2? All right, so if we do -2 here, we have 3 to the -2 -5. What is 3 to the -2? 1/9, right? 1/9 -5. Well, let me ask you this. What is 5 minus 1/9? It's going to be 4 and something, right? 4 and 8/9. But since the 5 is negative, it's going to be -4 and 8/9. Those type of ones I'm not going to expect you to do in your head, okay? That's why I gave it to you. I kind of explained my thinking, okay? All right, so we know this is -4 and 8/9. All right, give me another x value. -1. What is 3 to the negative first? 1/3. Minus 1/3 minus 5 would be 4. Negative 4 2/3. Okay. Again, those ones I would not really expect you to do without a calculator. Might want to pick some nicer numbers. So let's now, what's the next number we're going to pick?
I'll take 0 for 500.
All right, and when you take 0 for 500, what is 3 to the 0?
1.
What is 1 minus 5?
And 4.
That one we like, yes? That one we like?
I like it.
All right, works out nicely. All right, next one. Give me a number. 1. What is 3 to the first? Minus 5. All right, next x value. 2? You want 500? Okay, good luck with that one. What is 3 squared? Minus 5. 4. 9 minus 5 is 4. Okay? Guys, these ones you should be doing without a calculator. Yes? All right, plot your points and see if you can describe the transformation. Let's see if Ashley was right.
Okay. Ashley, are you right?
Plot your graphs, plot your points, draw your functions, and describe your transformation. Ashley, remind me, what was your guess? Down? Down 5? Did we move down 5? If we look here, if I start at my y-intercept of my f of x function, did we go down 5? Yes. So before we answer any other questions besides C here, so we shifted down 5 units. Where is my original asymptote? Y equals 0. So where would my new asymptote be if I went down 5? -5. So let's fill that in right now. Our asymptote will now be y equals -5. Because of the fact that you told me we shifted down 5, so what's 0 minus 5? -5. So my new asymptote here is at -5. I'm going to draw that in. So that's one thing that you need to be thinking of is how did my asymptote change? All right, let's answer some of these other questions. Knowing that our asymptote is at -5, what is my range? -5 to infinity, good. Our domain we should all know. All right, let's see if you can answer those last 3. Intercept, end behavior, and interval of increase, decrease. When you finish, look up, check your answer, only when you finish. Do we have questions on this? Questions? On B. How'd we do? Good? Yeah? Alright, when you're ready, flip it over. Last page. I want you to give this a shot. Given f of x equals 4 to the x, write a function that would shift this function 3 units down. So try that one real quick on your own. 3 units down. What would shift it 3 units down? So how would I have to change this to shift it 3 units down? Oh, so we know minus 3. Do you want it inside the exponent or outside? Outside the exponent. Good. Minus 3 outside the exponent. What about for number 4 if we want to shift the function 4 units left? Inside. Is it going to, so we're saying plus 4? Like that? Yes. All right, what about a reflection over the x-axis? Negative in front of the 3. And a reflection over the y-axis? 7 to the negative x. Good. All right, I'm glad we know our transformations. So let's take this a step further. We're going to consider f of x equals 0.5 to the x, and g of x equals negative 2 times 0.5 to the x minus 2 as the exponent. First off, what is 0.5 as a fraction? 1/2. So I'm going to come here and I'm just going to rewrite this. G of x equals negative 2 times 1/2 x minus 2. This is multiple transformation. So who can tell me one transformation? We have a stretch. Okay. So if we look, where do we see the stretch? What part? The negative 2? Just the 2. We have a stretch. Stretch by 2. We have a reflection. What tells us reflection? The negative. Reflect over x-axis. Make sure you put that in there. What's going on? What else do we have? Shift right 2? Where do you see that?
X minus 2.
Good, the x minus 2 here. That tells us shift right 2. And what else? We have one more. Not really a transformation, but it helps us determine our exponential. We have a decay. And the only reason why I want to bring that up here is so then we know we have a decay. So that's not a transformation, but it helps us understand what our function is going to look like. All right, looking here, think about the type of exponent you might want. We have x minus 2. What number would you like as an exponent? You want to have negative 2? Okay, so what number would you plug in for x to get your exponent to be? Okay, so hold on. Don't tell me what number you want to plug in for x. Tell me what number you would like as your exponent. You would like to have 1/2 to what power? 0. Okay, so what number would you have to plug in? So what number minus 2 would give you 0? 2. 2. All right, so let's plug that in. So we have 2. I'm going to do some side work here. Negative 2 times 1/2 to the 2 minus 2. That would give us negative 2 to the 1/2 to the power of 0, which is? Negative 2. Anything to the power of 0 is 1. Negative 2 times 1 is negative 2. Questions on how I got that? No? All right. What's another number you might like as your exponent? 1, positive 1. So what minus 2 would give you 1? You want positive 1. What number minus 2? 3. Three minus 2 is 1. What's 1/2 to the first power? 1/2. What's negative 2 times 1/2? Negative 1. All right. What's the next number you want to plug in for x? Give me a number you want to plug in for x. 4. So we have negative 2 to the 1/2. What is 4 minus 2? 2. Okay, what is 1/2 squared? 1/4. We have negative 2 times 1/4, which would give us negative 2 over 4, yes? Which is negative 1/2. All right, let's do one more. What's the next number you want to plug in?
Let's do 5.
5? All right, negative 2 to the 1/2 to the 5th power. It's 1/2 to, not 5th. 5 minus 2 is 3. What's 1/2 to the 3rd power? 1/8. Good. Questions on how I'm getting these fractions? No? This would be negative 2 over 8. I'm sorry, what?
Joe says in trouble.
Yeah, how do you get those?
Here, so I'm doing 1/2 to the 3rd power. So what's 1 cubed? 1 times 1 times 1 is 1. What's 2 cubed? 2 times 2 is 4. 4 times 2 is 8. Okay? What's negative 2 over 8 reduced to? Negative 1/4. All right, let's start plotting some of these. Plot these points and then go ahead and answer the characteristics. 2, negative 2. What's my range here? Negative infinity to 0. Good. Anyone confused on range? No? Yes, you will. And I will show you how to do that. Check your information up here, and then I'll go over how to find the y-intercept. Joey?
Wouldn't, as x approaches negative infinity, it would be negative infinity?
That is negative infinity. Oh,
You put 0 for both of them.
thank you. Mine's working faster than my hand. All right, questions on any of this information? All right, where do we find the y-intercept? At what x value? 0. So we can come here and we can say, oh, we had, what was it? Negative 2 times 1/2, right, to the 0 minus 2. Show you real quick. What's 0 minus 2? What is 1/2 to the negative second power? So put it this way. We know the negative tells me to take the 1/2 and change it to a 2. What is 2 squared?
4.
What is negative 2 times 4?
Negative 8.
Negative 8. So your intercept should be right here.
Oh.
Was that super hard? No.
I'd rather not do it, but
We'll put it this way. How about this? Every time we make a table, we find 0. We put in the x value of 0.
I like what Joe just said.
What, not do it?
You know, we just guess.
No.
yeah.
No.
Sounds about right.
I'm gonna go to technical.
Okay, that works. All right. Let's start this next one. We're not going to do the whole thing because I'm pretty sure you guys know how to analyze, yes? So let's figure out, let's look here at this one. Tell me a transformation. What is a transformation we have?
Up 3.
Oh, what, Emmanuel? Up 3? Okay, so we shift up 3. And
What's the exponent?
left
Left 1.
1. Good. Inside the exponent tells you horizontal. Horizontal, you need to think opposite. So that would be
Shift 3.
shift 1 left, right?
Yeah.
Am I correct?
Yep. Yes.
Okay. Let's fill in a table real quick and graph it just so we get that practice in, and then I'll pass out your homework.
All right.
If we take a look here, we just learned what value should we put into our table right away?
0.
0. So if I plug 0 in, I'm going to get 2 to the 0 plus 1 plus 3. What is 2 to the first power?
2. So it's 5.
It's 5. Good. Right there you found your intercept. Give me another x value. 1. So we have 2. What's 1 plus 1?
2.
To the second plus 3. What is
7.
good? 2 squared is 4. 4 plus 3 is 7. If we notice, these numbers are getting bigger. So should I make my x values bigger or smaller?
Smaller.
Smaller. So give me a small x value. Let's go with negative 1. What is 1 minus 1?
0.
2 to the 0 is?
4, right?
2. Guys, 1. 1 plus 3 is 4. All right, give me one more.
Negative 2.
Negative 2. What is negative 2 plus 1? Negative 1 plus 3. So what's 2 to the negative first? 1/2. What's 1/2 plus 3?
2 and 1/2.
3 and a half.
Oh, 3 and a half.
All right, let's go ahead and plot these points here. We have 0, 5. We have 1, 7. They're not in numerical order. That kind of drives me nuts, but that's okay. Negative 1, 4. And negative 2 and 3 and a half. Since we know we are shifting up 3, what line can I not pass? Y equals 3. Because that is where we have our horizontal asymptote. So I would draw in a line so I know when I do this, I should not be passing that. Make sense? Yes? How are we doing with these?
Good.
Good?